You have equilibrium between liquid and gas. Young people, we can do the same thing. We can have equilibrium between solid and gas. Suppose you have ice. That's ice. Ice will have a chance to go to the gaseous state. Ice will have a chance to go to the gaseous state. Have you ever put ice in the refrigerator? In the ice tray, your metal ice, you're putting that in the freezer. Leave it for many, many months. Have you ever noticed that the cube of ice getting smaller? You have not done yet that? That's your experiment. That the cube of ice getting smaller. How come? There is equilibrium between the gas and the ice solid. If you increase the temperature, remember, ice doesn't need to be, it's okay, you can sign later on, guys. He's kidded you, it's okay. Ice doesn't mean 0. It could be -5, could be -10. As you increase the temperature of the ice, we're talking about ice. Every point here is equilibrium between solid and gas. You mean I can have ice and gas together? Yes. Yes, what do you mean? You don't need to, they will come back. You're so nice, go running around asking them to sign.
So what was the point of that?
Okay, let's go over this. We are doing experiment, liquid and gas. The higher the temperature, the more vapor. And we're drawing a curve. Every point, equilibrium between liquid and gas. We are doing another experiment with the ice. We are increasing the temperature of the ice in equilibrium with the gas, like subliming, yes, in equilibrium with the gas. And we are plotting another curve. Every point here is equilibrium between solid ice and gas. Young people, I'm going to take these two curves, these two, and I'm going to put them together, and that's what you're going to have on the top of page 5. I'm putting these two curves together, and we have something called phase diagram. I'm blending the two curves. This is one curve, this is another. Every point here is equilibrium between a liquid and gas. That's the very first curve. That's the very first curve. How about that curve here? That's the second curve. Every point here is equilibrium between solid and gas. Solid and gas. This is the second curve. So we are putting two curves together for the two experiments. There is one more curve that shows up here. Phase diagram. Phase means what? Solid, liquid, or gas. That's what we mean by phase. Watch this. We are still plotting temperature versus vapor pressure. I love the phase diagram. I'll tell you why in a minute. I will tell you why. The phase diagram tells me what is the physical state of the water at a specific temperature and a specific pressure. When the temperature is 100, and if the pressure is 760 torr, temperature is 100 degrees, and the pressure is 760 torr. We call this point here normal boiling point. When does the liquid boil? Do you remember? When the pressure of the atmosphere going down equals to the pressure of the vapor going up. When the pressure vapor equals to the pressure of the atmosphere, we call that boiling point. If it happened that the external pressure, the pressure of the atmosphere, specifically 1 atmosphere, we call this normal boiling point. Anything on this side at any temperature here has to be in the gaseous state. Anything in that region has to be in the liquid state. Anything in that region has to be in the solid state. Watch this. I'm working at 1 atmosphere. That's 1 atmosphere. And I'm telling you, water has a temperature less than 0. Let's say -5. So where am I on that diagram? I am here, -5, temperature -5. This is about 0. -5 should be somewhere here. And I'm working at 1 atmosphere. What would be the physical state? It should be solid. Watch this, look at my question. What will happen? I'm working at -5 degrees, and I'm working at 1 atmosphere. You told me it's supposed to be solid, water in the form of solid. And I'm asking you, I'm still working at 1 atmosphere, and I'm increasing the temperature. What am I supposed to see? Solid? Don't tell me liquid. No, no, no. Solid? Then what do you see here? Solid and liquid on that line, yeah? Then what do you see here? Liquid. Young people, you're not going to see solid, then immediately you're going to see liquid. What are you going to see? Solid. You're going to see the solid melting. This means you're going to see two phases. Then one after that, liquid. Great. Now, I'm not going to stop. I'm still working at 1 atmosphere, and I'm increasing the temperature. What will happen to the liquid water as we increase the temperature? Don't tell me it's going to become gas. What would I going to see here? Liquid. I can tell you how many people say, oh, you're going to see solid, you're going to see liquid, you're going to see gas. I said, no, no, no. You forgot the transition stage. There is a transition here when you're applying liquid, applying heat. What is the heat doing? Breaking the bonds in the liquid. So you have equilibrium between liquid and gas. Look at this. What does this line tell me? The higher the temperature, we're going higher to the right. The higher the temperature, the vapor pressure. The higher the vapor pressure. How about this line telling me? The higher the temperature, the higher your what? Vapor pressure. How about this line? What does that line represent? Equilibrium between solid and liquid. Would you call that solid and liquid together?